Hi, I'm Stefan Eeskens. I'm an Azure specialist and a Microsoft MVP. I have a particular interest for artificial intelligence. I have been involved in several AI-related real-world projects in the past 3 years. Therefore, I want to share some lessons learned and of course some technical bits with the community. Please follow me on Twitter, as I'll keep sharing extra bits and I'll be announcing the upcoming of new episodes. This course is made of multiple episodes, and some of them might not be recorded yet by the time you watch the current episode. The course explains some fundamental AI concepts and will slowly increase in complexity with real-world examples and concrete business scenarios that could be relevant to your enterprise. You will learn how to create and consume Azure Cognitive Services, as well as how to educate more advanced services and specialize them to fit your specific needs. No technical prerequisite is necessary, as I will try to be as exhaustive as possible in my explanations. However, the course is primarily intended to developers, but part of it is accessible to non-developers as well. In the previous episodes, we've seen what AI is all about in the Microsoft ecosystem, and we built a chatbot that is able to respond to IT questions and day-to-day conversations using QnA Maker. But although QnA Maker is a great tool, customers often want to leverage their information where it sits and do not want to duplicate it in QnA Maker. Moreover, QnA Maker is great when it comes to simple questions and answers, but what about documents and what about data that is stored in a database? In this episode, we're gonna see how to leverage external data sources from within the chatbot in a natural way using LUIS to capture entities combined with part-of-speech tagging made available by the Linguistics Analysis API. The data sources I'm gonna deal with for the demos are a SharePoint site and a SQL database. Before we jump to demo mode, I'd like to elaborate a little bit on part-of-speech tagging. This definition extracted from Wikipedia makes it clear that post tagging is about identifying each word in a phrase and the role it plays into it. The post tagging operation takes into account the context of use to determine whether a given word is a verb, a noun, etc. Post tagging makes use of very complex algorithms behind the scenes, but fortunately we won't need to worry about that thanks to the Linguistic Analysis API. To give you a concrete example, if you perform post tagging against the phrase "I live in Brussels", you'll get 4 tags in return, each corresponding to one of the words contained in this phrase. So, how can we take this to our advantage? Say that you have a SharePoint site containing plenty of how-to documents in PDF and Word formats, and you don't want to spend time in building corresponding QnA Maker services, but you still want to leverage this source of information from a chatbot. Let's see a concrete flow. A user asks the question, "How can I install OneDrive?" This question is sent to the Linguistic Analysis API to perform the post tagging operation. We get the following tags back. We decide that it only makes sense to keep verbs, nouns and adjectives. So we end up with the following tags VB and JJ, which corresponds to install OneDrive. From there on, we perform a search query over SharePoint programmatically from the bot. By the way, if you're a little lost with all the grammatical categories, you can go to a very handy website that lists them all. But hey, don't you think we could do better from within the chatbot? We got rid of non-meaningful words thanks to the post tagging. But if we send the phrase "install OneDrive" as is to SharePoint, isn't there a risk for noise? What if another document says something like "a prerequisite to using blah 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 is to install OneDrive"? We'll get that document as part of the result, although it might be related to something else. What if we use LUIS to extract entities and make them match to tags in the document management system? In this case, we can bet that a document containing the words "install OneDrive" and that is tagged with OneDrive is really a how to install OneDrive document. Using LUIS to extract entities should offer greater accuracy in the results. That's what I'm going to show you in a minute, using both SharePoint and the database. Note that another method to capture the essence of a piece of text is available through the Text Analytics API, but this isn't convenient to use in the user search scenario since it makes use of asynchronous jobs under the covers, and we have no control over the time this job kicks off in the cloud. I'll elaborate on this API in the next episode. On top of using post tagging, I'm going to cheat a little bit as I will also make use of lemmatization. That's not made available yet by the Linguistic API. Hopefully Microsoft will add this in the near future. With post tagging, we can keep only words of a certain category and eliminate the others, but we can go further than that by using lemmatization. So, I give you 10 seconds to read this Wikipedia definition, and then I'll give you a concrete example. Not that easy, right? In other words, lemmatization is the process of regrouping all the inflected forms of a word into a single one, taking into account the context of use. In the following example, the words in red all belong to the verb to be. So we'll make use of lemmatization to exclude verbs and nouns we don't want to keep in the final search query we'll send to either SharePoint, either SQL Server. Unlike the other episodes, I will first show you the user experience of using natural search from within a chatbot against two external data sources, namely a SharePoint library and SQL database. I'll explain after how to get there, but since it's by far more complicated than all the things we've done so far, I'd like to give you an incentive first, in the hope of providing you the necessary energy to understand. That said, here is the SharePoint library storing a few documents containing the description of my Channel 9 course. As you can see, I have used enterprise keywords to tag the documents. These tags match the IT topic entity defined in LUIS as we've seen in episode 3. From the SharePoint UI, if I try to search for documents using natural query, SharePoint won't find anything, as it is basically trying to find documents that contain all the words I'm providing, and of course there is none. Let's now switch to our chatbot, where I have already implemented the call to the Linguistics Analysis API and the post tagging operation. If I provide the same query and I use a mention-like approach @doc to facilitate the LUIS understanding, the chatbot finds a document in SharePoint. The same goes with another query. Notice the natural way of asking things. If I open this document, I see that it is indeed talking about auto-tagging in the context of a chatbot, which is by the way something we'll see in the next episode. Now I have the same type of information stored in the database. The other type of data source I want to interact with, where I have a simple table and a tag column, similar to the SharePoint Enterprise keyword. Now if I prefix my query with @dbdoc, I'll be able to get information from the SQL database in a natural way from within the chatbot, the same way I did with SharePoint. So here's a recap of all the steps that were required to build what I've just shown you. We'll first have to create the service, but beware that it's not yet available in the Azure portal. Then, as usual, I'll show you how to consume it with Fiddler. I'll explain how I integrated the service to the chatbot, and I'll finish with the explanations about how I integrated with SharePoint and SQL Server. For the time being, you can only use a trial key for the Linguistic Analysis API. To do so, simply navigate to the following URL and sign in with a Microsoft account and get the key. Now that you have the key in hands, you can consume the service. As usual, using the Composer tab of Fiddler, I'm building my HTTP post request to the service. I provide my key, and in the request body I specify the piece of text to analyze as well as the identifiers of the analyzers. For the time being, there are 3 analyzers. The analyzer that finds tags, the analyzer that finds phrases, and the analyzer that returns all the tokens and their position in the text. We're mostly interested by the tags and the tokens. So when we execute this request, we get the results back. The tag analyzer returns all the tags. Unfortunately, you don't get the corresponding token in the same response, which is a bit annoying. The phrase analyzer returns both the tokens and the tags in a specific way that's not easy to parse. At last, the token analyzer returns every token and its position in the text. In order to facilitate the parsing of these responses, I wrote a NuGet package, which I'll briefly describe shortly. Okay, let's come back to the LUIS app we created in episode 3, as it is the first layer of understanding. So, in order to deal with the user requests, I have created the two following intents. I trained LUIS with a few iterances to make sure that he understands the prefix trick I showed during the demo. Also, as you can see, LUIS already extracts entities such as NLP, etc. As a result, in the chatbot, when the code corresponding to an intent kicks off, it will get the extracted entities, which I can reuse to build my search queries against external systems. Okay, back to the code of our chatbot. Here is what I changed since last time. First of all, I have added a few NuGet packages in order to deal with the Linguistic Analysis API, the database, and SharePoint. As said before, I have developed my own NuGet package for the Linguistic API, as the previous one developed by Microsoft isn't working since the API was moved to the cognitive services. However, what I did is really minor, so you could replicate that yourself. Let's have a look at this NuGet package to see what I did there. As we saw with Fiddler, the Linguistic Analysis API doesn't return side by side the tokens and their corresponding tag, which is often what we need when we perform a post-tagging operation. That's basically what the method analyze text is doing, as it is regrouping tags and tokens and returns a list of token and tag objects. On top of that, I also added some helper methods that allow you to filter directly on verbs, nouns or adjectives. Back to our dialog, I'm dealing with two intents to interact either with SharePoint, either with SQL Server. We'll have a look at the SharePoint flow first, triggered by the find documentation intent. We first start by removing the add-doc prefix from the message, since we just use this trick to facilitate the branching to this code. Then I sanitize the original input by removing entities from the text. Indeed, I plan to use the extracted entities as tags in my query, so they don't need to be part of the search text when sending the query to SharePoint. There is no need to dive into that method, as it is not very interesting. However, the next goal is to get information from SharePoint, but I first call the post-tagging operation, so let's have a look at both methods. In the post-tagging method, I first declare a few lemmas that I want to exclude from the resulting search query. Verbs such as know, wish, like, etc. are polluting the query and might generate silence in the search results if sent as is. Then I instantiate my linguistic client that comes with the NuGet package, and I call the analyze text method, which will return me all the tags and tokens into a single list. I then keep only the verbs, nouns and adjectives, but I first make sure they are not bound to an excluded lemma. Let's now see this in action. The following sentence results in the following search query. As you can see, tags were extracted by LUIS automatically. Then I simply make use of the client-side object model of SharePoint to perform the search query against my SharePoint site. And I return a list of paths to the caller, meaning my dialog. Okay, so far so good. A short break before we see the SQL part. The sequence of actions is as follows. A user sends a piece of text, LUIS resolves the intent and extracts the entities, the code calls the Linguistic Analysis API thanks to my NuGet package to perform the post-tagging, the code generates a query with the filtered words and converts the extracted entities to tags. The code calls the external system. We've just seen this in action with SharePoint, but I did exactly the same with SQL Server. The only change is that I'm using Entity Framework to interact with the stored procedure I created in SQL. So, as stated before, all the steps involved in querying SQL Server in a natural way are the same as for SharePoint, but instead of using the SharePoint search engine, I have developed a stored procedure which I'm going to show you now. This procedure takes two arguments, the verbatim, which is the user input, minus the words we have eliminated with post-tagging, and the tags that were extracted by LUIS. I start checking whether the verbatim contains a space indicating multiple words, which I would in this case convert into a list of near statements in SQL Server. Then I'm checking whether some tags were transmitted or not, and I build my SQL statement accordingly. Note that in order to use the contains operator in the SQL query, one must make sure the target column is full text indexed, so that's what I did with the abstract column. In this episode, we've seen how to use post-tagging in the Linguistic Analysis API to our advantage in order to query external systems. In a natural search query scenario, post tagging is a good way to capture the essence of a sentence by eliminating noisy words. However, while this can offer great results, it also comes with limits as it works well with short sentences but isn't suitable for lengthy pieces of text. Post tagging can be used in many other scenarios and natural search is only one of them. In the next episode, I will show you how to tag and route documents automatically by leveraging the Text Analytics API. Please follow me on Twitter and feel free to share your thoughts via the rate and comment feature.